Okay, so we had just gone through the flags that are used um to see if the configuration state is for a given router is at assigning via Slack only, via Slack with stateless DHCP, or via stateful DHCP. And these are the values that are within the flags. With the flags, managed other auto configuration for Slack is 001, 011 for stateless DHCP, and one managed. Stateful DHCP, everything is being managed by the server. Stateless DHCP, other parameters are coming from the stateless DHCP, and there is still an element of auto configuration. With auto configuration only, the value is one here. No other, no managed, and basically that's it. Now, answering our questions. Which question will we do? Which statement describes the effects? Right. A network admin configures a router to send RA messages with M0 or 1. So when we have M0 and O1, it means that is Slack with stateless DHCP. So that is stateless DHCP. That's that is basically what is the RA message is instructing. It's instructing a client to use stateless DHCP plus Slack to get an IPv4 address, IPv6 address. Which statement describes the effect of this configuration when a PC tries to configure its version 6 address? It should contact the server for the prefix length information, interface ID, both random and unique. No, that's other. It should contact the server just for other, not that is everything there. Yeah, we need it for other only. It should use the information that is contained in the RA message and contact a server for additional information. Voila. That's our answer there. Other. I won't go through the other answers. Let's save our time. Refer to the exhibit. What should be done to allow PCA to receive a version 6 address from the server? So this is PCA. It needs an address from the server. What should be done? So these are all configurations. The interface 00. This one is getting an address dynamically. That's one. It's IPv6. Then we have managed config flag. If the flag is managed, then it means we're getting everything from a DCP version 6.7. So that's stateful. So this router is instructing via the RA message, clients should get an address using the managed flag, which is using stateful DHCP. I think that is what we can get from everything that is here. Right. Uh, Answers. Add the IPv6 DHCP relay command to the interface. What's the question again? What should be done to allow PCA to receive an address from the server? Okay. Add a relay NetScope interface CP. This could be an answer because self-array on a PC, they're on different networks. The server is on a remote network, so this could be an answer. Uh, Someone tell me if the relay is configured on this interface or on this interface. That could prove to where our answer is for a start. Right, change the IPv6 ND manage to IPv6 ND other. This is wrong because if we change this to other, then we'll be getting our address uh from Slack. It could be correct. It could be correct. If we change from managed to other, we still need a relay. So this is not correct. What we need here is a relay because we don't have a relay here on our commands here. I think that's where our response is. We definitely need a relay. Even if we change this and we don't configure a relay, then we will not be able to get to the server because the server is on a remote network. So I think our answer is definitely on the relay there. Configure IPv6 managed and no relay. Add IPv6. I think this is our answer. And it also answered where the relay is configured. It's configured on the interface where the client is. If you configure it on this side, how will this interface know that there's a broadcast which is coming from this interface? Because it will not be able to forward it to this interface. That's a different network there. Routers do not broadcast. They do not forward broadcast traffic. So this is our answer here. Okay. We go to 22. Answering questions can actually be interesting. Refer to the exhibit. A network administrator is implementing a stateless DHCP operation. Stateless means other. So we are getting other information from the server. That is stateless. Clients are configuring version 6 addresses as expected. However, the clients are not getting the DNS server address and the domain information configured in the pool. What could be the cause of the problem? Clients are configuring version 6 addresses as expected. However, they are not getting the server. So probably the problem here is with we don't have access to the server. So with stateless DCP, we are getting our address from Slack. We are getting other from server. The other here, don't open a DNS app. So if we are getting addresses, but we are not getting this, it means we don't have access to the server. That's our answer. Let us see. The DNS server address is not on the same network as the clients are on. That could be an answer. If it's not on the same network, then there is need for a relay. That could be an answer. The router is configured for Slack operation. What do we have here? Slack operation. How do we know? Unicast enable who created server settings, everything proper, interface, the address, configured as a server, and okay. Right. Let me think. The router is configured for Slack. This could be an answer as well because we didn't change the flags here. Yeah. Okay. Right. Okay. So this could be an answer as well because our flags by default IPv6 enabled routers, they use Slack only, meaning the flags are at A is equals to 1 by default. So if you want to use stateless auto configuration, then on your commands, you need this command. I've seen it somewhere here. You need this command here. This one with other here. So it's IPv6. This is very important, I think. So by default, IPv6 enabled devices sends RA messages and instructs the client to use Slack to get their addresses by default. Now, if you want the RA messages to instruct the client to use stateless DHCP, Slack with stateless DHCP version 6, then we will need the command IPv6 nd other config flag. If you configure this, then it will mean the RA message will instruct use Slack with stateless DHCP. If you want to use stateful DHCP version 6, then the command is IPv6 nd managed config flag. So what we are getting from a response edu, this can also be an answer this one. Reason why, it's because, let's see, let me get some. Right. So I said this can be an answer. I'm answering the wrong question. Where are we? Here, 22. Right. The DNS server is not on the same network as the clients. No, this cannot be an answer. There is no DNS server. It doesn't need to be on the same network or on different networks. If it had said the DHCP server is not on the same network as the clients, then that could have been an answer. Why? Because if it's not on the same network, then we'll need to configure it as a relay as well. We'll need to configure one interface as a relay. But since they said DHCP here, it's no longer an answer because we don't have a need for the DHCP to be local. We don't care if it's remote. What we are getting from the server, the other part, what we're getting from the server is the address of address of the DNS server. We need the address. We don't care if the DNS server is remote. So this is not an answer. Then this one, I said it can be an answer. Why? Because there is no configuration in Wuchinja from the default, which is IPv6 ND managed or IPv6 ND other. The gig Ethernet interface is not activated. Can we verify that from here? Not activated. We cannot verify that from that. We cannot see if it's not it's activated or not. From the commands, it seems like it's not activated, but we cannot verify for sure. Let me see the last answer. The clients cannot communicate with the server evidenced by the number of active clients being 0. Maybe it is not assigned an address yet. That's why the clients are 0. I'll take B for this one. In our wildest imaginations, this can be an answer. If that interface is not activated, then it won't be able to act as a server, will it? But we don't know for sure if it's not activated. The route is configured for Slack operation. So here We are using stateless DHCP. However, our router is not configured for that. So what happens? What happens is the addresses will be acquired via Slack, but we will not be able to get the DNS addresses because we have not configured the router to send an RA message with M is equals to 0, O is equals to 1, and A is equals to 1 message. Number 23. Number 23, there is no question there. Number 24. The company uses Slack to configure IPv6 addresses for the employee workstations. Which address will a client use as its default gateway? The company uses Slack. Okay, we're using IPv6. The default gateway for IPv6 is always the link local. Link local, let me see. The global unicast, no. The unique local, no. The O, no. The link local. Link local, no, no, specific default gateway. FE8, what? That's the address that is used for the default gateway. 25. Refer to the exhibit. Administrator is configuring a router for version 6 operation. Which conclusion can be drawn based on the commands? This one is to enable. We've created a pool. This is the save address, domain name, interface, GUA, configure it as a server, and the other. Right. We have changed from default. We are now using stateless DHCP. So command ERI, it basically means router ready is now sending more messages and RA is instructing client to use stateless DHCP version 6 to get other parameters. Then Slack to get the IP address. So which conclusions can we get from there? Let me see. Right. Let me close a few things here. Right. So the router is configured for stateless DHCP. No, we've done this one. My PC is slowing up. Something wrong. Let me see. Yeah. Okay. Right. Where are we in Africa? Number 25. So network admin is configuring a router for DHCP. Which conclusions can be drawn? Right. So we've seen it as interface enabled. We've created the pool parameters are there. And we've also seen we are using stateless DHCP. Answers. The router is configured for stateful, no, stateless. DHCP server name is Arcade class. This is not the server name, this is the pool name. Clients would configure the interface IDs above 0010. What is this? I'm not getting this answer. The router is configured for stateless DHCP. That's a valid conclusion there. 26. A network administrator is analyzing the features that are supported by different first hop redundancy protocols. Which statement describes a feature that is associated with hold standby? HSRP. So when we talk of first hop redundancy, router redundancy protocols, we are talking of grouping of routers so that they can share the virtual IP and the virtual MAC address. How does it help us? It helps us in providing redundancy in our IP default gateways. If a default gateway from a physical router fails, then it does not affect connectivity to remote networks. Why? Because we're using a virtual IPv4 address. So in short, what the first hop redundancy protocol does is these two routers, for example, they are treated as a group. So they have a virtual IP. Then they have a virtual MAC address as well. So instead of these devices using, for example, this specific default gateway, they no longer use default gateways of a physical router because if this link fails, then these devices cannot communicate remotely. With FHRP, first hop redundancy, if this one fails, then the protocol allows a change. This router probably will become the router which is in control of this virtual IP. Then the virtual IP is being used and it's always there. That's basically the idea behind first hop redundancy. Instead of having a physical router which has a physical interface which is being used as the default gateway, we now have a group of routers. All those routers, they share a common virtual IP. So even if one of the routers fail, the virtual IP stays, meaning the default gateway stays. That's the basic idea, I think. Now, which statement describe a feature that is associated with what standby? This is correct. What standby? It uses active and standby routers. Then we have another one, which is the virtual router redundancy protocol, which uses it should be the backup. It uses the backup routers instead of the standby routers. Then what standby is proprietary, so this is false. What standby is Cisco proprietary. It uses just a minute, 10 minutes. Right. So, what standby it uses? It's a Cisco proprietary, which uses active and standby routers. The other one, VRRP, is ¿Qué pasa? Where are we in Africa? Is my screen still sharing? Yes. Right. So the other one, I think these are the two protocols which are used, which are the most common. HSRP, Cisco proprietary, VRRP, open source. And it uses it should be the master and the backup route. Then it allows load balancing. No, there is another protocol which allows load balancing. Is this one? Gateway load balance protocol. Then it uses ICMP in order to assign the default gateways to the host. Nope. Uh, this module I think was one of the shortest modules that we ever did. All right. Let's go to refer to the exhibit. What protocol can be configured on gateway routers, R1 and R2, that will allow traffic from the internal LAN to be load balanced? Every time you hear load balancing, this is the protocol for load balancing with respect to gateway redundancy. So GLBP not only offers gateway redundancy, there's also an element of load balancing. And what do we mean by that? Right. Without load balancing, what we basically have is routers, physical routers, acting as either the standby or the active router. And the active router being the one which uh, sort of controls, owns the virtual IP. It is responsible for the virtual IP. So if one of if the active router fails, then the standby router comes in, and we always have a default gateway, and it works like that, no issues. However, with load balancing, it sort of acts the same way. If you remember Ether channel, we said Ether channel, we have multiple links. Each of those links, uh, kana transmitter, let's say we have three links, transmitter 3 MB. What will happen? One channel up, one channel up, one channel up. That is basically what load balancing is. Instead of having all three zero and nothing here on these links, Ether channel, it allows us to bundle this so that we can load balance. So we can have one, one, one. That is what load balancing is. So with this protocol in load balancing is, it allows us to use these multiple interfaces, multiple routers to load balance traffic when we are trying to route. So it not only offers redundancy by my default gateways, but it also offers load balancing. That's the protocol right there. STP, nothing to do with STP here. Right, then we go to 28, which refer to the exhibit. Network engineers, a network engineer is troubleshooting host connectivity on a LAN that uses the first hop redundancy protocol, which default gateway should be configured on the host. So if we are using the redundancy protocols, the address that is configured on the host is the virtual one, the virtual IP. There it is. This address here is the one that is configured on hosts. The address which is on the interfaces, on the routers, the physical routers, it's not used. So here, this is the address of the standby router. This one is not used. Where's the active? Active is local. Where is the IP address of, this is the IP address of this one. Group members, okay. This is the IP address of the active. This is the IP address of the standby. These are not the address which are used as default gateways. Instead, this address, which is the virtual one, is used as the default gateway. So our answer here is .100. That's the whole idea behind first hop redundancy protocols, making use of the virtual IP instead of the physical IP addresses. Unfortunately for CCNA, I don't think they went as far as configuring the routers to act as virtual groups. I don't think they did. Right, 29. Refer to the exhibit. Which destination MAC address is used when frames are sent from the workstation to the default gateway? Here is the MAC address of the virtual router. Easy. That's the MAC address which is used. All right. I'm struggling with the power. Question 30. Let me just do this. Hopefully I finish. Question 30 is presented. Where are we now? Question 30. Right. There is no question for number 30. There are no answers actually. I think that's an error somewhere. Question 31. Which first of redundancy implementation is Cisco proprietary that supports IPv4 load sharing? This one. That's Cisco proprietary gateway load balancing. Address pool of DHCP is configured as 1092.71.0. That's the pool. The network administrator reserves 8 addresses for servers. How many addresses are left in the pool? Right. Understanding a subnetting comes in here. Here must subnets. So if we have a slash 25, it means we have a total of 26 usable addresses. If we remove 8, how many do we have? 126 minus 8, 118. So addresses left is 118. This one needed knowledge is subnetting. If we have slash 26, Msakangana is CCNA 1 because Mam CCNA 2. Slash 25 is 126. Slash 26 is 64, that's 62 then. 27, that's 32, 30, 28, 16, 14, etc., etc. Question is represented. Someone in the chat. CCNA 1. Yeah, Magabaneko. His introduction to networks. Yeah, joke. You found that funny. 34. I think this is the last question we do. After a host has generated an IPv4 address using DHCP version 6 or Slack, how does the host verify that the address is unique? DAD. We call that duplicate address detection. It uses NS messages and NA messages. Let's see our answers. The host sends an ICP echo request to the land address. If no reply is returned, the address is considered unique. Is it an ICMPv6 echo request? I know it's a neighbor solicit message. Question mark here. The context is correct. I'm not sure the wording is. Question answer B, the host sends an IP. Yeah, the answer is there. Enable solicitation to the DHCP or Slack land